Okay, this second example is a little bit nastier than the last one. I've put a few more terms in. I did deliberately put this one in here because I knew that people have been struggling with this. In this particular exponential, we've got the base is a half, but the power is also -1. And this is kind of something we should try and avoid and that our index laws can deal with. With that index law about negative powers, we're told that 1 on x is the same as x to the -1. What this is saying is you can have a fraction or you can have a negative power, okay, and they are equivalent to each other. Both are kind of messy. They're not the nicest thing, but often you can use one or the other. You shouldn't use both. So in this case, we've got a negative power and a fraction. So we can use that index law to actually tidy up here. So if you actually just consider what a half to the power of -1 says, well, that says that 1 to the -1 on 2 to the -2. 2 to the -1, golly, I'm struggling here. This is still 1, so I'm going to get 1 on a half, and that tidies up to be 2. So I can actually use this negative power to flip it back to being just a base of 2. And if I do that and sketch that graph, that's a little bit nicer to deal with. Okay. Now on the right hand side here, I have copied that kind of base exponential, 2 to the x function properties. Let's think about what this guy looks like by comparison. How do these two parts impact on our graph? Well, just like the last one, the asymptote, not just like the last one, just like the last one, the y-intercept, okay, is going to be multiplied by this leading power. We'll deal with that in a second. I shouldn't have gone on to that. We will talk about the asymptote first. Okay, so let's go through it. Base exponential has an asymptote at the x-axis. In this expression, there's two terms that are affecting it. This 4 here, that's quadrupling the height, and then after that, the +4 is shifting the graph up by 4 units. So just like in the last one where this leading 4 didn't change the asymptote, it's the same. Okay, if it was only this term here, I would still have an asymptote of y equals 0. But the +4 shifts everything up, so we have to add 4 to that. So our asymptote is actually going to be y equals 4. Similarly, y-intercept, okay, well, it's actually going to be affected by both parts. Just like the last question, I've got to multiply by 4, but then this constant term will add 4. So I'm actually going to end up with a y-intercept of 8. Oh, the clock has come up. There we go. Now, my x-intercept. This one is a bit nastier to work out. Depending on the question, we may or may not have to work it out. I'm actually just going to leave it. I'll work out the rate of increase. Okay, it's still 2. That means it's still going to double in height every unit it goes along, but it doubles in height from the asymptote. So that is something to be aware of. Okay, from y equals 4, and I'll show you what that means when we get to sketching it. Okay, so let's have a look at that particular graph and mark those things on. As always, I always mark my asymptote on first and my y-intercept on first, and that will make things a lot easier. So I'm going to have another go at sketching on a tablet. That was much better than last time. I'll go further this way. Oh. And that one was just as awful as last time. Okay, again, we don't really have to worry too much about scale relative to the x and the y-axis. Like the y-axis should be in scale with itself and the x-axis should be in scale with itself. But if the units on the y-axis represent different things to the x-axis, that's okay. So here we've got to have a y-intercept of 8 and an asymptote at 4. So I'm going to choose a half scale because that'll give me a nice kind of sketch going on here. Okay, so that's where I'm going to put my intercept at 8 and my asymptote at 4. So let's draw that asymptote in there. Oh, a little bit off from the calibration. Okay, now this rate of increase, the rate of increase is 2. That means the function has to double in height every unit it moves to the right, but it doubles in its distance from the asymptote, okay, not from here. So the distance here is 4 units or 2 squares. So when I move 1 unit, I've got to go up by the same amount again. So this is my point I'm going to go through. Okay. When I go another unit, I've got to come way up. It's going to be like up here. That goes past my axis, but I'll use that as a guide point when I sketch. Similarly, the distance to the asymptote halves each unit I move along to the left. Okay, I've probably made this a bit too big, my x-axis length here, but that's all right. So let's try and join that up. Again, I've got my hand on the inside of the curve here to help get a continuous curve. Oh gosh, this is really hard on a tablet. There we go. So we'll go along there, and in reality, I should probably just make my axis go to here, and that'll be fine, and just ignore what's happening over here. So that's going to be my graph of this exponential function. And I don't know what I was thinking, this clearly has no x-intercepts, so we don't need to worry about those.